Maybe you've come across these. Or perhaps you've heard or seen words like these. This course is about all of these and then some. Welcome to Analytics and Predictive Modeling, a course on building models for big data. I'm Dr. Jeff Nicely, your instructor, member of the CARDS Institute, and this course is actually an entry course for the Masters in Applied Data Science program offered through the CARDS Institute. This Masters in Applied Data Science program is an emphasis on data science, analytics and learning with very large data sets. The goal is to present a multidisciplinary program designed to train professionals to work with large data sets. Analytics and predictive modeling begins the program's goal of training professionals by introducing models used to study complex data sets. So analytics and predictive modeling, well, first off, an analytic is an inference from data that's used to make a decision or a prediction. For example, diagnostic testing produces an analytic. The analytic is the probability of positive for a given disease. A predictive model is an assignment of a probability to every possible outcome of a process. It's what a machine learns in the field of machine learning. A predictive model is a probability distribution, and the predictions of such models are often the analytics we're interested in. So generative AI is roughly sampling of a predictive model's learned optimal probability distribution. There are generative models that are not samplers, and there are predictive models that do not lead to generative AI. But very often, generative AI is a sampler, and that's going to be our focus. Data science tends to be the application of convex optimization and numerical linear algebra to big data. Optimization means differential calculus. Probability means integral calculus. And these are the prerequisites for the course, calculus and linear algebra. Which brings up a natural question. What is data science? Well, let's ask an expert. ChatGPT. So here is my question. What is data science? And ChatGPT's response.
Data science is an interdisciplinary field that involves the extraction of knowledge and insights from data. It combines various techniques, tools, and methods from statistics, computer science, and domain knowledge to analyze and interpret large and complex datasets. The primary goal of data science is to extract meaningful information and actionable insights from raw data, enabling data-driven decision-making and solving real-world problems. Key components of data science include data collection, the process of gathering relevant and diverse datasets from various sources, including databases, APIs, web scraping, sensors, and more. Data cleaning and pre-processing, preparing the data for analysis by dealing with missing values, removing noise, and handling.
Is not a fancy Google search. This is what's known as a large language model. And a large language model generates a unique response from a variety of, quote, Googled sources. It can even tell us what data science is in the style of the author Ernest Hemingway.
Data science, a modern alchemy. From the depths of ones and zeros emerges meaning, like fish rising from the murky waters. The art of numbers, a dance of statistics and machines, woven with the threads of human wisdom. Raw data, a rugged landscape, is tamed and molded, revealing its secrets through careful observation and experimentation. The models, like characters in a story, come alive, predicting the future and unraveling the past. In this digital age, the scientist wields the quill of code, crafting narratives of insight, etching graphs and charts that tell tales of patterns and truths. And thus, from the tangled web of data, emerges knowledge, a beacon in the fog of uncertainty.
So, not surprisingly, a large language model requires huge amounts of big data, as does this natural reading of the, quote, Jarvis vocalization. Data science is the study of such big data. In this course, the components of data science, well, they come straight from ChatGPT. Data collection, raw data from one or more sources, exploratory data analysis, data cleaning and preprocessing, data representation, also known as feature engineering, data modeling, which is algorithms and or equations, model evaluation, well, how good are your results, and communication and visualization, which are very important. If you cannot present your results in a comprehensive, detailed story leading to recommendations and good answers to their questions from your clients, then what good is all this work you've done to your clients? You have to be able to tell a story. We'll learn how to become what's known as strategic thinkers. That is, data science is an umbrella term for all of these things, all of which are related to big data. Data science is a cross-cutting interdisciplinary field that has emerged in response to the rise of big data. We're in a big data revolution. Nearly 100% of the world's data has been generated since the year 2000. In 2012, an average of 2.5 quintillion bytes of data every day. Now, how big is that? Well, here's 2.5 million, and billion, and trillion, and quadrillion. That many bytes of data every day. Most is big data, enormously large data sets. Much of it exists only briefly in the cloud. Each of us, for example, generates several megabytes a day of actionable information, where we go, what we buy. The Large Hadron Collider produces more than 6 million gigabytes of data every second. Such data sets are, not surprisingly, high volume, very large, high velocity, computationally expensive to apply algorithms to, and high variety. But then you might ask, well, doesn't the central limit theorem say we can predict a statistic with only a few thousand observations? Couldn't we just sample our big data and then avoid issues with volume, velocity, and variety? That is, why bother? Why not just use old-fashioned small samples from the big data and then just analyze the small samples with our tried and true statistical techniques? Well, big data is very good data. Data that can answer questions we could only dream of answering a few years ago. But it does it via predictive models, probability distributions, that are too large and complex for traditional statistics. Self-driving cars, precision agriculture, personalized medicine, personalized learning. IBM Watson beats the Jeopardy legends. For example, there is a revolutionary model now that's far beyond simple statistics. ChatGPT. It's a chatbot, an artificial neural network trained to produce human-like responses to questions. It is a data science model built on a set of big data that includes the entire internet as it was in 2021. It's a generative AI model that samples responses from a probability distribution on billions, probably now trillions, of random variables. Indeed, ChatGPT is revolutionary. It can write full-length novels and screenplays, high school and college essays, translate from one language to another. But it also can say things that are false, these are known as hallucinations, and it can respond in ways that are just not useful. That is, ChatGPT is amazing, a true C3PO model for AI-human interactions. but it's many light years away from being R2-D2. It's great with languages, but what about science, technology, engineering, math, medicine, so on and so forth? Fortunately, we already have R2-D2s. For example, the Mars rovers. Although navigated by drivers, their survival requires they act independently. Here's Vendi Verma, Curiosity and Perseverance rover driver. They have to avoid rough terrain and choose smooth paths. They have to avoid shade that blocks their solar rays. And they have to do this on their own. The original missions were expected to last days or months. Curiosity was launched in 2012, and more than 12 years later, it's still up there running around on Mars. Here's a rover's neural network training session. So you can see they mock up the Mars landscape, and then they actually have the neural network in a computer. And once it's fully trained by this model, it's uploaded, the neural network is, into the rover that's sent to Mars. We actually did this with some area high school students. They really liked it. We also did a smart highways project, AI to eliminate traffic congestion. And here's another R2-D2 style model, computer vision. It's already an indispensable technology we rely on every single day. Driver assist in newer cars, self-adjusting robotic arms, medical imaging. Nearly all MRI data uses computer vision. And there are some things we may not like. Ethics is a huge issue in AI. Now we will explore these and many other examples of C3PO and R2-D2. But first, let's better introduce ourselves to a particular type of model of big data. The next video is going to be a more in-depth look at the generative models known as large language models.